Hi, it's me again. So as promised, this is the answer for example 2 or example 2.2 in the slide. In this example, you are asked to find the vertical displacement at joint E of the truss. The elastic modulus of each member is 210 kilonewton per millimeter square, and the data are as follows. The data are all given in the table because they are not constant. The L is different for certain members. The area, the cross-section area of each member are also different. Okay, the first step to be solved is to determine the reactions at the support. Here in this example, we have 3 reactions: HA, VA, and VG. We first determine the reactions VG by taking moment about A, where we have summation of moment at A equal to 0 as shown in this equation, and solving this equation will give us Vg equal to 80. So this Vg 80 kilonewton is acting upward. Then we can find the next reaction, which is VA, by summing or by equating the summation of Fy acting upward to the summation of Fy acting downward. From this equation, we get VA equal to negative 20 kilonewton. So if we originally assume the VA is acting upward, but when we have actually the VA is negative, we have to change the direction of VA. So it will become VA equal to 20 acting downward. Okay, once we get the reactions, we proceed by determining the internal forces F of each member in the actual structure due to real forces 20K at point E, F, and G, and also at H. This is the actual structure because we have not put the one virtual load at point E yet. Okay, so we put all the reactions at A and at G together with the applied forces. Kemudian kita determine the height and the distance from each point. In this case, we have 9 meters from B to H and 20.2 meter from A to B and from B to C. Okay, and using this triangular, we can come up with an equation, mathematic equation here, to determine the easiest internal force. We start with, let me erase this first. Okay, we start with joint A. at joint A, we have 20 kilonewton acting downward, and we have 20.2 kilonewton internal force. No, I mean we have the distance 20.2 from point A to point B. So here we can see that the only reaction in Y is FABY. So directly we know that FABY is 20 kilonewton acting upward. Okay, so this is the FABY equal to 20 acting upward. There's no other upward forces other than this. Yeah. From this equation, from this FABY, we could determine the FAB in X direction by using the triangular atau mathematic triangle ni ya. So we have 20 times 18, because 20 is in Y direction. So we want to change it. We want to find the X direction. So we multiply this FABY with the X direction, and we divide it by the Y direction. So we get 40. So FABY is 20. FABX is 40. So we can find the resultant force FAB from the equation 20 square plus 40 square, and then square root all together, we get 44.7. Therefore, the FAB is now 44.7 tension. Okay, so the rest of it is again using simplified method. We go from one joint to another joint. What I did was again, I find it quite difficult if I continue with simplified method, where I need to solve at certain joint using simultaneous equation, like the one that I showed you last week. Yeah. So what I did here was I cut across here, and I can find the internal force FGF, FGD, and FCD from using moment equation. Okay, in this example, I take moment at G. Okay, hold on, I delete this first. Okay, I take moment at G here, G, because I want to cancel FGD and FGF. I want to cancel this. It leave me with FCD only. Okay, then by taking moment at G, I create the equation mg ikut jam sama dengan kosong. So I get this equation. From this equation, I get FCDX equal to 60. Okay. FCDX, this is again mathematic equation here for me to find the FCDY. So I get FCDY 30 kilonewton, and from the resultant force FCD is 67.1 in tension. Okay, and then I move to joint B. Again, using the simplified method, I will get FBG equal to 22.4. Now that's wraps up all the internal forces in the real structure or actual structure. And then we move to finding the internal forces mu in the dummy structure. This is the dummy structure. When we put the 1 unit load at E and we throw away all the applied load, it becomes dummy. Okay, again, I first find all the reaction by taking moment at A equal to 0. So these are the reaction that I got. Vg is 2 kilonewton acting upward, and Va is 1 kilonewton acting downward. Okay, so I repeat, you don't have to repeat cutting the section here, yeah. Since this most of the internal forces here are 0, it is easier than the actual structure. Okay, let's see now. We start with A. We start with A. We have VA equal to 1 acting downward. Therefore, the AB acting upward here should be 1 also. And from there, I can get the FABX, which is half of it. Which double it, because the y distance is 9 and the x distance is 18. The y distance double from the y distance. Therefore, the force of AB in x direction is also should be double than the force in the y direction. So if the force in y direction is 1, therefore the force in x direction is 2. So we get 2 here. Okay, and we can continue like at joint H. This is joint H. This is joint H here. Okay, as you can see at joint H here, we have 2 kilonewton acting to that joint H, and 2 kilonewton and there's no force in y direction. Therefore, the BH internal force become automatically 0. Okay, and since H is 2 acting to point H, therefore the GH force is acting to the direction of point H, similar, which is 2 kilonewton. So these are all the answers that I got. And I then tabulate all the forces F and mu in this table according to the earlier table provided in the question. And at the end of at the far end column, in the far end column of this table, I calculate the F times mu times L over A. I don't include E here because E is similar in every member. I only include E here. After I have find the summation of F mu L over A. So from this equation, I get the answer of the vertical deflection at joint E is 3.769 or 3.77 millimeter. Okay, so that is the answer. Please try to do exercises at the back of the slide of chapter 3, and I will let you know which exercise that I expect you to submit via Google Classroom very soon. Okay, I hope you understand how to get this, and I really hope you guys practice and practice. Okay, finally, stay safe everyone. Goodbye.